Hello and welcome to Unit 8, Kinetics and Equilibrium, Lecture B. Today we're going to talk about what factors will increase or decrease a reaction rate. So the factors that are affecting it are based on this concept called collision theory. So in order to have two particles react, they're going to have to collide, and they're going to have to collide in the specific direction and with the right amount of energy. So if you remember enzymes, I talked about enzymes in biology being like a key in a lock where the shapes have to match up. Think of what happens if you try to unlock a door but you put the key in upside down. The key just won't fit, and so you're never going to unlock the door that way. It has to fit the right way. Same thing is going to happen with reactions. So collision theory says that our particles are going to have to hit directly. And when they say directly, they mean in the right position for the reaction to happen, and with enough speed, because we said that in order to break the existing bonds, energy has to be absorbed. So if they don't hit hard enough to create that activated complex where they're breaking the original bonds, you're not going to get a reaction. So if they're going too slow, no reaction. If they're not facing the right way, so if you have the oxygen side in this example hitting again, no reaction. They have to hit in the right direction with the right amount of speed in order for the reaction to happen. We can influence those factors, whether they're in the right direction or not, and if they're moving with the right amount of speed to make the reaction happen faster. One of the most important things that you're going to do is change the concentration. So if I have 1 molar HCl, that says I have 1 mole of HCl particles per liter of solution. But if I use 6 molar HCl, remembering that that means I now have 6 moles of particles in the same volume, I have more particles. They're going to be crowded together. So if there are more pieces crowded together, you're going to get more collisions, and you greatly increase the odds that your collisions are facing in the right direction, because the more pieces collide, the greater the odds are they're going to match up the right way. So the more concentrated it is, the faster the reaction rate. When you have chemistry and we have shorthand all of the time, one of the things that I want you to watch out for are the square brackets. If I have something and it says square brackets HCl, that means the concentration of HCl. Square brackets, concentration, it's just one of the shorthands you should know. Okay, temperature. You know that temperature means the average kinetic energy. So if they need more energy to make sure the collisions are happening correctly, then we can speed up how much energy they have by raising the temperature. More speed means we get more effective collisions. There's going to be a spot where if they're going too fast, they might fly right off of each other, kind of like when you play pool. If you hit the cue ball too hard and it just glances off one of the other ones. But in general, increasing the temperature increases the speeds of the particle. More of your collisions will be effective. They'll have the right amount of energy. Your reaction goes faster. If you have a solid, now surface area is only going to work if you have things that are solid. We can increase the reaction rate by breaking it into smaller pieces. So if you have solid versus a powder, the powder is going to react faster because there's more surface area. The more surface area there is, the more individual pieces are in contact with the environment, and the more collisions will happen. So greater the surface area, the greater the reaction rate. One of the things that they'll say is if you have, a 10-gram cube versus 10 1-gram cubes, you have the same amount of reactant, but the 1-gram cubes, because there are 10 of them, will have more surface area and it will react faster. And last but not least is to add a catalyst. If we add a catalyst, remember all we lower is the activation energy. since it takes less energy for a collision to be effective, more of your collisions will work. The other things that catalysts sometimes do is that they hold them in the right direction. If a catalyst is holding one of your reactants so that the area or section of the particle that needs to be collided with is facing out, then your other reactants only have one choice. They can't hit them in the back, they can only hit them on the correct side. And so that will also help speed up the reactions. Sometimes it stresses the bonds. So by holding it, it kind of tugs it and pulls it open so that the bonds are weaker. And that's put stress on the molecule, which means your collisions need less energy for them to happen. So adding a catalyst, also a great way of speeding up a reaction. Okay, so big picture here. In order for reactions to happen, we need to have effective collisions. Effective collisions are ones that happen in the right direction with the right amount of energy. If we can make more collisions and we can make those collisions harder or faster, then we will increase the odds that our reaction will happen.